Our last help video here, friends. The most important thing here is vocabulary. Alternate exterior angles are angles that are on opposite sides of the stir stick outside the line. Corresponding angles. Same side of the stir stick. One is in, one is out. That would be corresponding. Alternate interior, of course, would be the infamous armpits of the Z. That would be alternate interior. First and foremost here, we have parallel lines. Now, it tells you to find certain angles. I would get in the habit of just finding everything possible in the diagram and then just plug the numbers back in. And so you just, what I call, walk it up the ladder. So 102, vertical angles, 102, armpits of the Z, 102. And then this is also corresponding to this down here, 102. You got a linear pair, adds up to 180. So this is going to be 78. Corresponding angle, 78 here, vertical here, or alternate exterior angle, 78, 78. And then you just pick off the angles that are being requested. I want you to solve for X and Y here. So the things you want to watch out for are things like this, linear pairs, of course, which add up to 180. Also watch out for congruency, things that are congruent, like these guys, which are alternate exterior angles. And of course, this only works when lines are parallel, which you are told. So we can't use a linear pair here yet because that would give us two different variables. So we're going to use the congruency. Our thing equation is angle equals angle. 81 equals 6y minus 129, and you solve from there. So we have 210. Divided by 6, of course. And we find that our y is 35. So y is 35. 81. And then to solve for x, of course, you simply subtract from 180, so that's going to make this 99. Down here, you have parallel going both ways. So we have M and N parallel, which is going this way, parallel. And then we also have P and Q parallel going this way. So they're parallel both directions. You have two different stir sticks. Solving again for X and Y. Taking a look here, we have the 81. So we're going to start with that one. So 81, and because of the parallel lines, I have armpits of the Z, which makes this 81. And then alternate exterior angles, which makes this 81, which would make this angle right here, adds up to 180. That would make that green angle 99. Let's solve for X and Y. Y, armpits of the Z, would also be 99. So Y here would equal 99. Solving for X, we have here 3X plus 33 equals 99. Or we could have done this, 3X plus 33 plus 81 equals 180. Either of those would work. And of course here, x equals 22. We're considering this line, so I'm going to put it in the big margin, y equals 3x minus 2, and our slope is 3/1. Parallel, slope equals slope, so 3/1. Perpendicular, it is the opposite reciprocal, so it's -1/3. Coming here, our slope is -1/2, y equals mx plus b. Parallel, again, the same, slope equals slope, -1/2. Perpendicular is the opposite reciprocal, so it is 2/1. We're doing parallel and perpendicular, but what you notice is that not all of these are y equals mx plus b form. So that's the first thing you have to do. So for this one, I'm going to divide by -2. And we get y equals -5/2x minus 3. And this one we get y equals -2/5 x plus 1. And then this last one, we're going to do in the margin, 10x minus 4y equals -8. Minus 10x, we have minus 4y equals -10x minus 8. And we get y equals, the double negative makes a positive, and reduce, that's going to be 5/2x plus 2. Now you look at the slopes. And you start comparing. This is line 1, line 2, line 3. So we're comparing, first off, lines 1 and 2. They are not the same, so they're not parallel. They are not opposite reciprocals because both are negative, so they're not perpendicular, so they would be neither. And then 1 and 3, 1 and 3, they're not the same because one's positive, one's negative. But they're also not opposite reciprocals. So they're not parallel, they're not opposite reciprocals, they are neither. This last one, 2 and 3, they're not the same, so they're not parallel, but they are opposite reciprocals. -2/5, positive 5/2, check, they are perpendicular. So the trick to this is you have to make sure all three get into y equals mx plus b form first and identify your slopes carefully. All right, consider the line. Y equals 2x minus 4. We're going to do two things. We are going to do the perpendicular going through this point, 3, -3. Find the equation of a line. When it says equation of a line, that means y equals mx plus b. Keep that in mind. And then we want the parallel going through the same point. So we take a look up here. First, you want to establish what your slope is. The slope of your given line is +2. So your perpendicular slope, is going to be -1/2, and your parallel slope is going to be exactly the same thing, which is 2/1. Using this information, you are going to do A and B And our goal is to get y equals mx plus b. So watch how we do this. So I'm going to color code this for you for both of them. That 3 is your x. It's going to go right there. That -3 is the y. And the -1/2 is the slope. Over here, the 3 is still the x. The -3 is the y. And 2 over 1 is your slope. You plug it in. Okay, now you solve for b for both of these. Okay, so here we have -3. This is going to make -3/2 plus b. On the right, 2 times 3, that's 6. So we have -3 equals 6 plus b. Remember, this is perpendicular. This one's parallel. This one's the a. This one's the b. Obviously, life gets a little interesting here, so it's probably easier to change that into a mixed number. So -3, that's going to be -1.5 plus b. So we're going to add 1.5. And if you, basically this is a subtraction problem. If you have $3 and you take away $1.50, you're going to end up with $1.50. And so this is going to be -1.5 equals b. Over here, it's a whole number, which most of you like a little bit better. So your final equation for the perpendicular one is going to be y equals, and your slope is -1/2 x. Change that back. ALEKS prefers an improper fraction, so that's going to be -3/2 is your equation there. Here your equation is y equals, and your slope is 2/1x minus 9. That would be the answer to A and B. Nine and 10 are proving parallel lines. So 9 and 10 are read like this. Remember, we first learned this. If lines are parallel, then you have a bunch of different kinds of angles that are congruent or supplementary. Proving parallel lines says, if you have these kinds of angles, then the lines are forced to be parallel. So right here, we are given the fact that we're starting with parallel lines. So you're told that x and y are parallel. And we're being asked, how do you know that 8 and 1 are therefore congruent? This is literally a two-step problem, literally. So your proof is going to look like this. Statements is how ALEKS likes it. Statements. reasons. So we're going to start with our given, the fact that line X is parallel to line Y, and the reason there is given. Now watch the order here. We're starting with parallel lines. Now we can say that angle 8 is congruent to angle 1, and the reason is if you have parallel lines, then alternate exterior angles are congruent. That's why do I do alternate exterior? Because that's what 1 and 8 are. So make sure here the order is if you have parallel lines, then this is true. That's the order for number 9. Number 10, the order is exactly opposite. All right, taking a look here. What is our given information? R is parallel to S. And it tells us specifically we're not allowed to use the transitive property of parallel lines, which means one's parallel to the other, parallel to the third. These are parallel, so we can't use that. So we are given that R is parallel to S, and we are given the fact that 6 is congruent to 2. We're trying to prove that R is parallel to T. Okay, so you just kind of think, so somehow we need to get R, the reds, congruent, which means this, 6 is congruent to 2, and if the blues are parallel, so kind of keep in mind, if the blues are parallel, that means we can get 7 and 6 congruent because of alternate interior angles. And then we're going to transfer congruency from 7 to 6, and then 6 to 2. And then our punchline is going to be the fact that 7 and 2 are congruent, therefore the lines are parallel. That's where we're going with this. Statement reason. So number 1, I know that R is parallel to S. Now I'm going to find what's immediately true because of that. What's immediately true because of that is that angle 6 is congruent to angle 7. Why? Because if I have parallel lines, which I do for the blue, let me color code it. If those blue parallel lines are parallel, then alternate interior angles are congruent. Look at the order. We're given parallel lines, so parallel lines go first. Now we also know that angle 6 is congruent to angle 2. Why do we know that? It is given. Look at the connection here. If 6 is congruent to 7 and 6 is congruent to 2, that means we can now connector piece. Angle 2 is congruent to angle 7. And the reason there is the transitive property of angles. think it might just say transitive property. You transfer to congruency. 2 goes to 6, 6 goes to 7, therefore 2 and 7 connect. That's called the transitive property. And because 2 and 7 are armpits of the Z, that forces these lines to be parallel. So step 5, R must now be parallel to T, and the reason is, look at the order, because of alternate interior angles. If alternate interior angles are congruent, then the lines are parallel. So just to clarify, step 2 says if you have parallel lines, then you have these angle relationships. Step 5 says if you have the angle relationships, then you have parallel lines.